Okay, ladies, here are the last bit of notes from class yesterday. What we're looking at here is limits numerically. We've looked at them graphically and we've looked at them analytically by considering the function, and now we want to look at them from a data table. All right? We're going to start with this function, f of x equals x cubed minus 1 over x minus 1. We know that x cannot equal 1, and so what we want to figure out is what's going on at 1. Now, if we could draw the graph and take a look at it, we could look at this and see if we can factor it. I'm not sure if y'all remember how to factor a difference of cubes, but let's say we don't want to deal with that. We want to look at this instead numerically. So what I want you to do is grab your calculator and put into your calculator y1 equals x cubed minus 1 over x minus 1. And we're going to make a nice big table. With some x's and the resulting f of x's, and we're going to let our calculator help us generate those values for us. So that's the table that I need you to draw. Okay? If we looked at this on a graph, we would be looking at what happens as x approaches 1 from the left and as x approaches 1 from the right. So we're going to put in some numbers here that get closer and closer to 1 from the left. So I'm going to kind of load those in backwards. 0.999 is very close to 1. 0.99 is not quite so close. 0.9, again, close, but just a little bit further away. And you're going to take your calculators and compute the values that go in the table for that. So that means that you want to go back to the home screen, just as a reminder. One way to do it is go back to your home screen and type in y1 equals, and that's under theirs, V-A-R-S, your theirs. Theirs, some of y'all say bars, but it stands for variables. And then you're going to go to y theirs. And then you're going to choose choice number 1, which is function. And up on your screen, y1 will pop up on your home screen. And it'll say y1. And then you put parentheses. And inside the parentheses, just put the number you're interested in. Your calculator will treat that like a function, and you'll be able to get the number out of it. You can also do it by going to your table. That's an acceptable way as well. For either one of those, make sure that you know how to type these into your calculator and get these values out. Okay? Without drawing a graph. And so we're looking at what's happening as x gets closer to 1, what is happening to y? What is the f of x value? Okay? Then we're going to take a look on the other side and look at what happens as x is getting close to 1. I'm writing this backwards. But as x gets closer to 1 from the right-hand side, so a number that's really close to 1, 1.001, 1.01, 1.1. Just these are some numbers that a lot of people usually use. And we're going to take a look at these 3 values as well. And I want you to actually make sure you practice this. Make sure you are getting the correct values out of your calculator. And we're looking at what's happening to the y values. As the x values get closer and closer to 1, what does the y value seem to be getting closer and closer to? And I think once you've got the table filled out, you can see as x gets closer to 1, both from the left and from the right, f of x is getting closer and closer to 3. So this is called looking at a data table to do your analysis. So that means we're going to take this data, answer this question: what's the limit as x approaches 1 of f of x? And the answer is going to be 3. Anytime you have a calculator and you are told to find a limit, you can use this method, unless you are told to do a specific method. Okay? All right, just one more example, and that'll be all. Just so we can practice 2 of them. Okay, so here's function with a radical in it. And you can look down here, I think, and see. You can look down here and think and see that x cannot equal 0. That's going to give us that 0 over 0 indeterminate form. So our question is, what's happening as we approach 0? Okay? I'm going to make a big table again. X and f of x. And I'd like for you to have 3 values approaching from the left and 3 values approaching from the right. There's nothing magic about the ones that I'm picking. These are just the ones you see in most calculus textbooks. And I think they sort of make sense. So on the first one here, I want you to take x values that get closer and closer to 0 from the left-hand side. So really close to 0 on the left-hand side is negative 0.001. And then negative 0.01. And then negative 0.1. You just want to get things that are close and getting closer. And then on the right-hand side, it'll be the positives of those numbers. Okay? In your homework, there's a couple of problems where all I ask you to do is tell me what x's you would choose to make this work. And then practice getting this into your calculator, typing f of x into y1, and computing the values. So I would suggest you pause, compute, and then stop and come back and look at what I've written in. Hopefully you'll be able to read it. I'm leaving myself in quite enough room. Remember that f of 0 actually does not exist. It's not there at all. Okay, and once you get those values in, you're going to stop and take a look at what it looks like y is approaching as we get closer and closer to 0. You see it starts off as 1.94, 1.99, 1.995. Wait a minute. Another 9 in that one. And on this side, 2.04 something, 2.05, that's 3 zeros in there. So I think by looking at this, you can see that on the left side, it's getting very, very close to 2. It's just a little smaller than 2. On the right side, it's a little bigger than 2 and getting very, very close to 2. So as x approaches 0, f of x approaches 2. That's what we are getting from the table. We would write the limit as x approaches 0 of f of x. The answer is 2. Okay, that's it. And the last page of your homework has you working with this numerical information.